So let's go ahead and write another query now to query for the relationship. So what I'm going to do here now, after I've done this, we're going to start looking at Aubrey Plaza because I think she's very funny. And we're going to match P person acted in directionally towards movie, M movie. And actually, let's just grab that R. And we're going to return R. So in this particular case, we're getting all the people that act in various different roles inside of Scott Pilgrim versus the World. So you can actually query directly for these edges or relationships. Okay, let's put a where clause in here. Where p.name equals Aubrey Plaza. And then you want to return P, right? Because we want to find the person that acted in Scott Pilgrim versus the World. So that'll be Aubrey Plaza, right? Or we can look at the R. We can see that Aubrey Plaza in Scott Pilgrim versus the World played Julie Powers, right? Or again, you can return M, which will be the movie, which will be Scott Pilgrim versus the World. So this actually would give you every movie that Aubrey Plaza played. And in this case, we just have one movie in our database, but this would give you all of them. Okay, now what happens if I wanted to find everyone that acted in a film with Aubrey Plaza? Well, you can actually do that as well. So I'm going to say match P person acted in a movie, right? We don't even have to get a variable name because we're not going to refer to it. We're just looking for any movie that someone acted in with Aubrey Plaza. And then I can just do an arrow in the other direction here. Acted in. And then I'll have another person. So we'll just call this person, I don't know, Q. This is what I have in my notes. I don't know why I did Q. So another person like that, where p.name equals Aubrey Plaza. And we don't want it to return Aubrey Plaza because technically Aubrey Plaza has been in movies with herself according to our graph database. So we're going to say where q.name, and this is how you do not equals, is the angle brackets just together like that. Not equals Aubrey Plaza. Return q.name. So again, I really like, oh, I messed that up. Shouldn't be an arrow there. Right there, so this is actually not going to work because there shouldn't be an angle bracket there. There we go. So this is what it is. So P person, then you have just a minus sign there, acted in movie, and you have this other person that also acted in the movie, and then you just return the name down here. And so you can see these are all the people that played roles in films with Aubrey Plaza. Now imagine that you had 100 films and 1,000 actors, as you would get 1,000 actors back here. Pretty cool, right? Like I like Cypher as a query language because it reads very well, despite the fact that graphs are kind of complicated, right? There's a lot of interesting things you can do with graphs, but as long as you're just kind of like drawing your relationships between these various different nodes, it's pretty easy to query for them. Like, what if I wanted to find all the roles that these people played with Aubrey Plaza? It's totally possible. So I'm going to do the same thing here, except I'm going to describe R here and acted in. I'm going to say where p equals q.name, and then what I want to do is I want to return not q.name, I want to return r.roles. And you can see here, these are all the roles people played in films with Aubrey Plaza. It's wild to me that that's so easy to query for something like that. All I did is stick a variable here with r acted in, and then all I did was return the property of r.roles. So what if I want to query for everyone that was younger than Aubrey Plaza that played in a film with her? Again, terribly easy to do. Same query up here. Okay, and then here where instead of saying where q.name is not equal to Aubrey Plaza, all I have to do here is say where q.born is greater than p.born, and then just return q.name. And so these are both Brie Larson and Anna Kendrick played in a film with Aubrey Plaza, and they are both younger than Aubrey Plaza. Just to kind of show you something that, so you know how to do this, let's say that we wanted to create a constraint where movie names must be unique. Now, we all know that there's like 17 Godzilla films because they keep calling the films Godzilla, but for a moment, fathom for a second that a movie name must be unique. What you can do here is you can say create constraint on a movie, assert a.title is unique. And this is going to create an index, actually, where it's going to force movie titles to be unique. And now, if I try to go create another film called Scott Pilgrim vs. the World, it's going to say, you can't do this. I've been told that this is unique, so I'm going to hold this constraint to be true. So that's how you do unique naming with graph databases. So graph databases actually do have indexes. We'll get to that here in just a second.